Welcome to the video on how to use the TI-83 or 84 calculator to graph polar equations. So this will be your main method of graphing these polar equations right here. And to do so, you need to be in the right mode. So if you go to mode, you'll notice down here I have radians and degrees. Make sure you're in radians when you graph polar equations. So that's the first thing. Make sure that's in radians. But also, down here under function, it says FUNC, that's function mode. PAR is parametric mode. We'll get to that and use that a little bit later as well. And then POL, that's going to be polar mode. So if I go down to function and then scroll over, I want to make sure that I'm in polar mode. So go hit enter for polar mode. Alright, so now what we can do is go ahead and quit the mode menu. And now if I hit Y equals, you'll notice instead of Y1, Y2, Y3, now I have R1, R2, R3. So now I can graph these guys. So let's go ahead and graph a basic one. How about 3 cosine theta? Alright, your theta button is going to be in the same place that your X, T, and M button is. So this place where you usually hit X for Y equals 2X, things like that. The same button's going to work for T in parametric mode, theta for polar mode. So I'll just go hit that to get my theta. Close the parenthesis and then hit graph. So a lot of this is the same as your rectangular mode. You just have to make sure you switch the calculator. And so there I see a circle radius 3. It doesn't quite look like a circle. If you want it to look more circle-ish, you can go to the zoom menu and then Z square will make it more of a circle. The trig zoom still the regular trig. So if you want a square, now it looks more like a circle. So now it spaces out all your x units same distance as all your y units. So it can fit more on the x-axis, fewer on the y-axis, but it does give you a nice square grid right there. Alright. I'm going to change, or I'm going to go to the window menu, show a little bit here. So now you'll notice rather than just x min, x max, I also have these new theta min, theta max, theta step. We'll get to that in a second. Let me go and change these x mins and x maxes. So I'm going to make these go from, say, -5 to 5. We're not going to need too much more than that. And the y's also -5 to 5. So this -5 to 5. We'll keep the scale at 1. So now if I graph, I see that again. Again, I can hit zoom square. Okay. So that'll make it a square, but now on the basis of that y is 5 units. Okay, so it just changes the number of units in your x direction. Alright, let's try another one. So you'll notice it traces it out on a regular calculator. This one traces it out pretty fast, but on a regular calculator it's usually a little bit slower. So you can see as the r's go around from 0 to 2 pi, you can watch it trace it out. So let's graph one more here. So I'll go to y equals again. And this time I'll do 1 minus 2 cosine theta. Alright, so 1 minus 2 cosine theta. Graph that. Alright, so there I see one of these limicons or limicons with a loop. So this has a loop in the middle. And I notice I'm 3 out on the negative x-axis. Okay, what used to be negative x, now we're in polar, so that's the pi axis. And then -1 unit for that loop right there. Alright, a few things. If I hit trace, I can trace these out. And notice there's my theta, so that's 0. And as you trace out, it'll trace out all these points as I go around. So here my theta is going around. Now I notice 3.14. There I have my pi value. And I keep going, but one thing I don't particularly care for is that I have these x and y coordinates. I'd rather have theta and r if I'm going to be in polar form. So if you need x and y, you can have those, but the question is, how can I get an r out of that? Well, that's going to be in the format menu right above zoom. So if I hit second and zoom, here's format. So rectangular graphing coordinates, that's that rect GC. Polar graphing coordinates, polar GC. So in the format menu right above zoom, I can change those. So I'm going to go ahead and hit polar coordinates, hit enter, and then go back to my graph. So it's the same graph, The only difference is when I hit trace, now I get r and theta. So r and theta values as I go around. Alright, so I can trace r and theta all the way around until I get to 2 pi, and then at 2 pi it stops. Alright. If I need a little bit more, then I can go to my window and change this theta min, theta max, and theta step. So we'll look at that in a second. Let me go ahead and graph another one here. So let's graph, how about a sine of 5 theta? So let's try a rose. So we're going to get, let me just clear that out, sine of 5 theta. So this is going to be a rose curve, 5 petals, and if we graph that, there I notice it's out. And let me go ahead and put something in front of the y, that way we get a little bit bigger curve here. So let me go ahead and insert 4. Alright, so this is 4 times sine 5 theta. So now this will go out 4 units. Should be able to see it a little bit better. Alright, so now if I graph that, now I see a larger flower there. And again, if I want to trace that out, there I start at theta is 0, r is 0, and we'll start there and trace all this around. Alright, so let me go ahead and show you what happens. Sorry, there's something loud going on outside. So let me show you what happens if I change these values for theta. So let's say we make theta just go from 0, and then instead of 2 pi, let's go ahead and put in a pi. And you can still use your pi button, so I can make that pi if I want. As soon as you get off of that, it'll change it back to decimal, but you can hit pi, 2 pi, 4 pi, whatever you need to. So now if I graph that, there's what I get for that graph. But notice when I do my trace, okay, this time as I trace it around, instead of stopping at 2 pi units, I'm only going to be able to go to where theta is pi. So once I get to where theta is pi, then it's going to stop. Alright. Let's go ahead, oops, wrong one. Go back to the window. So let's try something like this. I'm going to change that back to 2 pi. And let's do step size of 1. Alright, so if step size is 1, I graph that. Notice what I get there. So this just looks like a bunch of garbage. So if you see your screen giving you a bunch of garbage, it's probably your step size. So if you go to your y equals, okay, or sorry, your window, notice the step size on this is 1. So what it's doing on the graph is every 1 unit, it's 1 radian, it's plotting a point. So 1 radian's about 60 degrees, so it's plotting 1 point every so often. Sometimes they come out negative, so we see a lot down here in quadrant 3, and then it connects them. So there's just not that many points that it's plotting. Even if we get more points that we want to plot, say we change the end value there, let's go all the way up to 8 pi, see what happens. Alright, so this is going to be 8 times pi, oops, 8 pi. Alright, graph. We got a lot more stuff, but it's still just a mess because that step size is too big. Alright, so we need a small step size to be able to counteract just this whole bunch of stuff in here. Alright, so I'm going to go back to window. I'm going to change that theta max back, and I'm also going to show you, you can use negative values for theta if you want. So I can plug in a negative, say 2 pi if I really want negative values. I can put in a positive 2 pi there if I really want to go up to 2 pi. Step size, I think the default is pi over 24. So I'll go ahead and put that in. So pi over 24, that's the default. Sometimes you need more, sometimes you don't need quite so much, but that's the default value right there. And then I'll graph it again. Alright, so now if I graph, okay, now I notice I get the same shape. Alright, so with this guy, those are just a few things that you can do to change. Again, you can trace this around. Now notice I'm starting right here at negative 2 pi, and as I trace this around, okay, eventually I'll get back to the same place where I was at pi. So there's negative pi now back down at the origin. So you can play with that a little bit. Sometimes notice the r here, negative 1.1 e to the negative 8. That's 1.18 times 10 to the negative 8. So that's practically 0. So sometimes your r will give you something like this rather than 0. You can just take those as 0 when you're plotting those out. Alright, let's see. I think there's one more thing I want to show you, and that's the calculate menu. So if I hit second trace, this is the calculate. Notice there's not a lot here. So with functions I had probably 6 or 7 things that I could do. The only thing I can do here is find values or derivatives. So these are derivatives that you'll use in calculus, or I can calculate a value. So really there's not too much that I can do there. If I graph, you can also just type in a number. Say you want the value at 5. So we'll just go to, let's say, calculate the value 5. Alright, so at 5 radians I get negative 0.529. So anything like that, you can calculate the value, but there's no intersect feature or anything like that. All of that is gone. I can do derivatives, values, but that's about it. But for our purposes, just tracing out these polar graphs, seeing what sort of shape they make, that's going to be our main purpose right there. Let's see. Let's do one more just for good measure. So let's try, this one's going to be 3 times, we'll do a sine theta plus cosine theta. So this is not one of our standard types of curves. So 3 sine theta, and then let's just do plus 1 cosine theta. So that should be theta. Alright, so let's see what that graph gives us. So there we see a little bit of it. Goes around, looks like almost a circle. Could be some sort of limicon or cardioid, but just a basic shape that goes out. If you start playing with the angles, that's where shapes are really going to take place. So if I go back, let's make this 3 sine of 4 theta. So let's insert a 4, and then the cosine of theta. Alright, so let's try that. So if I graph that, now notice I start to get this flower petal shape, but it's off center. Some sides are bigger than the others. That's because we're adding this cosine at the same time as taking this sine. And if you want to double check some of these, sometimes you'll get more petals if you make this a bigger range, say like 8 pi or 16 pi, particularly if you have fractions with the angle. But usually 0 to 2 pi is your pretty good standard window. Alright, that's about it for this video. If you have any other questions on what happens with the calculator, you can always let me know when I get back.